Anyone who's worked in IT for any length of time understands the difficulty in moving applications between systems. As a developer, you might want to move an application from your laptop into a test environment, or perhaps you need to migrate on-premises applications to cloud environments. The challenge is that as well as the application code itself, installing and configuring the application will often involve many changes to the host operating system environment. And more importantly, different applications will affect each other on the same system, often in undesirable ways. Perhaps your application needed a specific version of a library or framework, and another application on the system wanted a different version. We've all been there. Containers are the next evolution in virtualization. They are isolated, resource-controlled, portable operating environments where applications can run. And from within a freshly installed container, the user sees what looks like a physical computer that's just been installed, or perhaps more closely, a freshly installed virtual machine. There are many similarities between containers and virtual machines. Each runs an operating system, has a file system, and can be accessed over the network. Below that, though, the technology and concepts behind containers are very different from those of virtual machines. Let's take a look. With virtual machine technology, we start with a physical server and install its operating system. Then we add a hypervisor layer. This hypervisor controls and manages the virtual machines, but each virtual machine contains its own operating system. There are two basic types of hypervisor, those that run over a host operating system and those that run on the bare physical machine. The first group are typically called hosted hypervisors, and the second group are called bare metal hypervisors. A key advantage of the hosted hypervisor is that it abstracts away the physical hardware. The downside of the hosted hypervisors is that they're slower than the bare metal ones. Because a virtual machine emulates an entire physical computer, the operating system within the virtual machine doesn't need to be the same as the operating system on the host. For example, you could use a Windows virtual machine on a Mac OS or Linux-based host system. Applications are then installed within the virtual machines. When we move virtual machines around, we're moving around large objects. By comparison, with container-based technology, again we start with the physical server and install its operating system, but then we add the container management layer. Often this will be Docker. The key difference is that then we create containers above this layer. The containers share the same underlying operating system, but are isolated from each other. Configuration for the application stays within the container for the application. When we move containers around, we're moving much smaller objects. This is particularly useful if we're creating microservice-based applications. It allows us to have many isolated, lightweight services without the overhead of individual virtual machines. You'll often hear the name Docker used almost like a synonym for containers. This is because it's been the most successful implementation of containers to date. Similar technology has existed in other forms for over a decade, though. When container technology was first created, there were different container formats. To avoid the problems that this would have led to, the Open Container Initiative was formed. It involved many leading technology companies and defined a standard container format, based primarily on the existing Docker format. The standardization of the container formats also allowed the creation of container management solutions. Docker Enterprise Edition is an example of a commercial offering, and Kubernetes is a widely used free open source alternative. The Azure Kubernetes Service, or AKS, is an easy-to-use implementation of it within Azure and offers a fully managed container orchestration service. It's important to understand the difference between images and containers. Images are templates that containers can be created from. To manage the details and workflow for available images, Docker introduced Docker Registry. They also offer a hosted version called Docker Hub and a commercial product called the Docker Trusted Registry. The Azure equivalent of this is the Azure Container Registry, or ACR, and it's easy to migrate to. because it's compatible with the existing Docker CLI tools.